Hello Math 124 fans. I'm going to continue my exam 2 review. This one's going to be about related rates. Ultimately, I really like related rates. I know it's something that worries students because it's terms of setup, but I like that you sort of can, in many situations, get a sense of whether your answer makes sense. In addition, there's several clear things to do. So it's a question that's hard to leave blank. There's plenty of ways to get credit. So before I get into that, let me just point to a couple things. I think for this, I do have review sheets on this, but looking at my lecture materials, if you really need a more thorough review, might be a way to go. In particular, this is section 3.9. And so I hand this out in class. This is my review on related rates. It gives a process, but you really just need a couple ideas, which is label and figure out what you're given and what you want. I used to say what you know, but now I say, and you write everything down. Then you differentiate and plug your numbers in. The only rule is you really should differentiate before you plug your numbers in. If you plug your numbers earlier and take the derivative, it's just 0. Years ago, I went through all the homework, and these are the things you used. Now, that looks like a scary list, but you really should know the area of a circle and a lot of these things already. It's not as common that you use a few of these other ones, but I would just put them all in your note sheet. These are the things you used in the homework. Similar triangles, your trig rules, this is it. So we're going to label, write down all the facts we know, and then find what we want. So there you go. So if you've been going through the homework, you already have this kind of list of things you've been doing. Let's talk through it and try a few problems. The problems I'm about to do are all problems from old exams of mine. Let's see, this one is from my winter 2017 exam, so you can try it on your own. A spherical snowball is melting. At the moment when the radius is 5, its surface area is decreasing at this rate. Find the rate at which the volume is changing at this same moment. Include units in your final answer to indicate if your answer is positive or negative. So my governing principle, really for almost any math question, is what are you given and what do I want? Sometimes students make the mistake of letting themselves be confused before they've even written those things down. There's too many words, I'm scared. You got it right. I'm not going to let myself panic until I've written these two things down and what goes with them. This is an important part of just general problem solving. So what was I given? We're talking about a spherical snowball. So I would draw a picture. What would my picture look like? It would be a sphere. Oh, I'm doing a bad job. You don't get any points deducted for bad pictures. So did that really help me to draw that? Not that much, but it's attaching my brain. It's reinforcing that I'm reading and saw that it was a sphere. So I'm kind of expecting you need some sphere formulas. Looks like I was particularly nice because I reminded everyone what they were. At the moment when the radius is 5, its surface area is decreasing. So when the radius is 5 centimeters, they tell me so that the derivative of the surface area is -3. I probably should, now that I look at that looks funny to me, I want to say the derivative is -3 when the radius is 5. So they gave me that information. So I'm just categorizing things right now. I'm not letting myself be confused. Find the rate at which the volume is changing. That's what we want. So it's not hidden, but you need to have sort of a plan to decipher so you aren't just lost. This just goes for any problem. What are you given? What do you want? Whenever you get stuck, write those things down. Most of the time when students are having trouble, especially in these courses, is because they don't know the answer to one of those questions. Most of the time when we're stuck in life, it's because we don't know the answer to one of those questions. Okay. If you want a more thorough process, I did copy. Let me see if I can find it here. I copied from my review sheet. And you could add things as you're doing these problems to your review sheet. Here's a copy from my review sheet. Draw a good picture, label everything. So we should label R, V. I can't think of anything else to label. But these would be things you could add to your note sheet if you're preparing for this is, have I labeled everything? Well, I don't know what else to label besides R, S, and V here. It usually doesn't hurt to over-label. Have I identified what I'm given and what I want? Yeah. Now can I get any equations at all? So we're going to do a little bit of searching here, sort of exploration. I'm going to write down any equation at all that involves those three letters. Now they gave us all of them. So there's nothing really to find here. This is 4/3 pi r cubed, and S is 4 pi r squared. So honestly, in this particular problem, everything was given. Now, the key thing that makes this all go is identifying what's going on with your variables. All of them are changing. This problem is pretty dear to my heart because I just made a video about melting snowballs, and I used exactly this, and I'll put a link to it if you want to see it. Because we talk about this again in differential equations. This is just a problem you'll probably see again. All of these things are changing. This is changing. This is changing. This is changing. You should know this just by thinking about a melting snowball. When the snowball melts, the radius changes, the volume changes, the surface area changes. So none of those are constants. So the moment I write down the equations, I just immediately take the derivatives. You might say, should I plug in anything? Do not plug in anything till you've taken the derivatives of everything that's changing. In this case, everything is changing. Okay, sometimes you can simplify your life by realizing that something is constant, but if you're unsure, just take the derivative of everything. So I'm going to take the derivative with respect to t. The derivative of this is just 1 dv dt. The derivative of this is, see, I miscopied. The derivative of this is 4 pi r squared dr dt. There's that implicit differentiation in chain rule. This is going to be 1 times ds dt. And this is going to be 8 pi r dr dt. So to me, everything I just did is somewhat automatic. I wrote down what was given. I wrote down what I wanted. I connected the variables that were mentioned in the problem. I differentiated those. So you can sort of always do that and then go back and figure out what you want. Now sometimes there's other ways, like I could have combined, but to me all of that should be somewhat automatic. Okay, so what are they saying? They're saying when r is 5, what else can we say? When r is 5. So at this point, if you're unsure what to do, you could just plug everything in everywhere. And they're telling me this is 5. You say, well, I really want this. Is there enough to get me there? I see a way. What do I mean by that? So let's erase here. And I'm just talking through this. This is actually a short problem, but my goal in these videos is to show you how to, hopefully, how to think through these problems so you're not leaving anything blank. So I find too many students are leaving things blank. And I think there's a ton of ways to get credit on this page. Sometimes people make small arithmetic mistakes, but it really doesn't make, that's what I like about these sorts of problems is it should be something you can get a lot of credit on, hopefully all the credit. So I plugged everything in. 5 times 8 is 40 dr dt. So the radius is changing this way at that moment. And then we're done. We just need to plug that in here. So at this moment, this is negative 3 over 40 pi. Let's scroll up a little bit. So the question is asking me what dv dt is. It's going to be all this. So it's going to be 5 squared. That's going to be 25. I'm going to do a little bit of arithmetic as I go because 4 times 25 is 100. So it's going to be 100 pi times this negative 3 over 40 pi. Those cancel. Dividing top and bottom by 10. I hate multiplying until I absolutely have to. 10 over 4, I can simplify that further as 5 halves. And if you practice this as you're doing the homework, you can get to where you don't have to reach for a calculator very much. And I would encourage you to do this. So negative 7.5. If at this point you don't know what the units are, you can always go back and say, I'm computing dv dt. So the units on top should be cubic centimeters for v. The units on bottom should be minutes. I'll just check my solutions. Yes, doesn't look like I did anything silly. I am expecting it's decreasing, so there's a little bit of checking to see that it's reasonable. But I hope you saw the process. What am I given? What do I want? Label everything and write the equations, and then just take the derivatives of each of those. Okay, so that's our process. Let's try another one. So this is from another one, I think maybe the same exam. Let me see if I can pull it up. Yes, this is the same exam with just another question. A kite is in the air at an altitude of 400 feet. For years when we go to the beach, I always try to get my kids to play with kites, but every time I get them out, once they get in the air, they want to walk away, and I'm left standing with a kite. So they don't really like it that much. A kite is in the air at an altitude of 400 feet and is being blown horizontally at a constant rate of 10 feet per minute. Again, there's a lot of information. So just read on. You know what you're going to do. You're going to label, ask what you're given, and what you want. Okay, so it's at 400 feet. Sometimes people are like, well, I don't know what picture to draw. It doesn't matter. Just draw something. So I have this kite that's 400 feet high, and it's moving horizontally. Okay, I don't even know what picture I want to draw yet. I'm just kind of making some scratch work here. It's moving horizontally at a rate of 10 feet per second. So I feel like the sketching I'm doing is just sort of something to attach my brain to sort of make sure I've actually read it. From the person holding the kite on the ground. Thus the kite is remaining at a constant 400 feet. Okay, fine. For both parts, include units in your final answer. If your answers are positive or negative, your final answer should be simplified, blah, blah, blah. At what rate is the string being let out when 500 feet of string is already out? So we need to do some labeling. You should sort of draw that scenario and realize what's changing. The 400 is not changing, but as the kite moves over, and you probably did one of these, it's a popular one in homework as well, you have this string attached to it. So to me, it becomes very clear what to label, the things that are changing. Also, at the same time, you can be thinking about what are you given and what do you want, because that might help it so you don't have to label too many things. But to me, again, I don't know what else to label here besides this length, which I think I'd like to call X, and this length, which maybe I'll call Z. Why not Y? Well, I kind of want to use Y for this, except it's a constant, so I don't really need to label it. You could even label the area. You could even label the perimeter. None of those are needed because they're not part of what the question's asking. So what is the question asking? At what rate is the string being let out when 500 feet of string is already out? The question is asking about this. The question is asking about dz dt when z is equal to 500. Is there anything they told me? They told me this 400 and they told me this 10. What is that 10? It's dx dt. Should it be positive or negative? Is it getting away from me? Away from the person, so it's getting bigger. This is getting longer. That's how you decide positive or negative. Is it getting longer? Yes. There's our information. And now we know the goal. The goal is to write down some equation, any equation that has an x and a z in it. That's true in this situation. And you should see that we have a triangle there. So here's one of many. I mean, you could even do things like tangent of this angle. You could label this angle. But that would be wasted time. You'd be finding stuff you don't need to find. You know something about dx dt, you know something about z, so you really just want an equation relating those two. So my immediate thought is Pythagorean theorem. So I would say x squared plus 400 squared is z squared. And the moment we write that, we're essentially done. Both of these are changing. Don't plug in any numbers yet. Now differentiate and think of these as changing functions. So in our head, we're thinking this. We don't usually write this. And we're just using the chain rule. This is equals. And we're just differentiating. The derivative of this is going to be bring down the 2, it becomes a 1 times the derivative of the inside. Bring down the 2, it becomes a 1 in the power, take the derivative of the inside. How we typically write that is this, 2x dx dt. This one is 0 because it's a constant. It's not changing. Equals 2z dz dt. And now we are done. So you can see, you need this sort of plan of attack, but you can see the moment I was right here, I knew I had it. Why did I know I had it? Because I knew what I was given, I knew what I wanted, I knew it involved those two variables. And calculus tells us immediately the relationship between the rates. If you know a relationship between the quantities, you also know a relationship between the rates. You just immediately differentiate and you're done. Now, when we go to plug in, maybe this is a good exercise here, you sometimes have to plug it in multiple places to sort of fill everything in. So it isn't always immediate that you can just plug in everything to the derivatives and you're done. I mean, I would cancel the 2's because it's too easy to do. Okay, but I know that I'm going to plug in, let me just scroll up a tiny bit. I know that I want to plug in a 500 here, and I know that I want to know what this is. And I know that this is 10. This often happens that you're stuck with something else you don't know. And when that happens, before you give up, just say, is there any place else I can plug it in? How about right here? Can I find X? Yes. So they didn't tell you X as part of the problem, and that was because you can find it. Okay, so then you plug in everything, solve for what you can solve, and you should have it. So this is going to be 500 squared minus 400 squared. X is equal to the square root of that, which I think is, so it's 2500, 1600, that's 900. X is 30, plus or minus, but I know in the picture it's positive. Let's see if that matches my work here. Not 30, 300. It doesn't match my work. Oh, there's too few zeros here. All right, I got it. Good thing I am checking. Okay, so this is 300, and we're done. dz dt is going to be 300 times 10, 3,000 divided by 500, and so you get 6 feet per second. Sorry, I'm peeking at my notes just because I'm trying to focus again on ideas. So then it says, let theta be the angle the string makes with the ground at a given time. At what rate is theta changing at this same moment? There's not, I mean, at this point we've already put in the hard work. We need to label the angle it makes with the ground. So that's important we read that carefully. And we have a ton of stuff we're given. I could say C above, but what we know is dx dt is always 10. We now know that dz dt is 6 when z is 500. And we also know that x is 300 there. So we got a lot of stuff we know. And this is x and this is z. At what rate is theta changing at the instant when it's 500 units out? So I want d theta dt at this same moment. So I need some equation that involves theta and some of the other variables. Now, I don't need a formula that involves theta and x and z. If I can get away with just theta and z or theta and x, that might be better. Notice, even though it's on the other side, I know this is 400. I also know this is theta, so just pick your favorite pick. What do I want to do? So I just see many paths forward here. I'm trying to think of what would be the clearest path. If you can't see the clear path, you just start filling things in. And what do I mean by that? So first thought, what about tangent of theta? What can I say about tangent of theta? It's opposite over adjacent, so it's 400 over x. Success. That will solve the question. If we don't like that, we could say, what about sine of theta? Opposite over hypotenuse, 400 over z. You could also use something else, but at this point, I would just pick one. You don't need to think really hard about it. So let's say we want to use the tangent. Let's differentiate with respect to t. Sometimes when students have more choice, it causes more angst, but don't worry. Okay, so the derivative of tangent is secant squared of theta d theta dt is equal to negative 400 x to the negative 2 dx dt. And yeah, that looks sort of bad, but we can plug in the numbers everywhere. Now there's going to be a moment where you're going to come back here and plug in 300. and have to do arctangent. You actually don't have to do arctangent, because if you know that tangent is 400 over 300, and you know this is 500, there's a way to get secant directly. That'll be important when you go on to Math 125. You can also plug and chug, but secant is 1 over cosine. And cosine is hypotenuse over adjacent. So this is going to be 500 over. I talk about this in my class. This is a side discussion. But then you can solve and get that. I think at this point I'll stop. I have my daughter's fastball game to go to. But you can see more examples. You know, if you want to play this game, I have some other ones in my exam archive. This is from my exam archive from my winter 2016 exam, water dripping out of a cone. This is also from that exam. I think this is also a homework question. You label everything. You ask, what are you given? What do you want? Write down some equation that relates those variables and take their derivative. So I hope that gives you a little piece and kind of a picture of what this looks like. All right.